Hello and welcome to lesson 3 in interest and depreciation, simple interest graphs. Today we are going to be looking at the graphs of what we covered yesterday with simple interest. So we're using the formula that I equals PRN. As before, I is the amount of interest, P is the principal, R is the rate of interest, and N is the number of time periods. So there will be times when we know P and R. So often when you go to set up a savings account in the future, or when you need to borrow some money, you'll know how much you've got to invest, how much you've got to save, or how much you need to borrow. You'll know P, and you'll tend to know R based on whichever bank or building society that you're talking to. So if you do know P and R, then basically we've got an equation that's only got two things that could vary that come left. So there is I, the amount of interest, and there is N, the number of time periods. In other words, the amount of interest you pay is going to be dependent on how long you decide to borrow for. So that is the thing you can choose, how long you borrow for, how long you save your money for. That is an independent variable. I, the amount of interest, is the dependent variable. So a simple example says that an amount of $1,000 is invested for 10 years at 6% simple interest. We use the simple interest formula to complete the table of values. So when the time is years, I'll just write the first one up. Time in years is 1. The interest is equal to the principal of 1,000 multiplied by the interest rate 6% up here, as a decimal 0.06, multiplied the number of time periods, just 1, as we said before, is 1. Do that, you will get $60. For the second time period, for the second column in the table, the time is 2 years. So we would replace the 1 up here with a 2, and you'd get $120. Sorry, the tablet didn't pick up that O very well. We'd get $120, and as you can see, it's just adding on $60 a year for every year that we have it for, which would be great if it went up in 1 each time, but it doesn't, so the next one is 4, so replace the 2 with a 4, that'll give us 240. If you replace N, the number of time periods, with a 5, you will get 300. Finally, if you replace it with 10, you will get $600. So, if we use these values to draw a graph to show the amount of interest earned over a period of 10 years, first off, let's just label these axes. So the horizontal axis, our independent variable, is the number of years. Our vertical axis, the dependent axis, is the interest in dollars. So you've got quite a few points there that you can plot. Each little square here, there's 5 of them to go from 0 up to 100. So each little square, each unit is 100 divided by 5, which is $20. So when we have got just 1 year's worth of interest, we've got $60. That's 3 lots of 20. So we go up 3 squares. I place X's. You may place dots, whichever works for you. After 2 years, we've got $120. And so on and so on. It's always worth drawing a few points so that you can get a straight line that passes through all of them. If you make a mistake with any one single plot, like I've done there, you should notice that when you try to draw through them, there's one that's missed out. So a straight line that goes through all of them. This isn't going to work too well on my tablet, but we'll give it our best shot. So as you can see, I made a couple of mistakes here along the way. When I did 5 years, I was looking at 4 years, I plotted 240. It should have been 300. And finally, when I was doing that last one for $600 worth of interest, I accidentally went 1 year too far. So it should have been back there. So like I said, always try and plot 3 or 4 points. That way, if you make a mistake with one, then the correct ones at the start will show you the mistakes that you made and just let you catch them. That's what your graph should look like. The next questions in the booklet ask us to determine the gradient and what this represents. So to determine the gradient, we basically need to pick 2 points on the graph that we know for sure. Because they're easy to work out, let's use these points. So the one at 5 years and $300 and 10 years and $600. We draw a right angled triangle underneath. So gradient is equal to the rise over the run. The rise here is going from $300 at this point up to $600 here. So the rise is 300. The run is the change in the horizontal distance. So from 5 years here to 10 years here, we've got a total of 5 years as the difference. So the rise over the run is 300 over 5, which is $60. So I'm just going to swap pages onto the second one now. On the previous page, we said that the gradient was the rise over the run. We calculated it to be 60. What this represents is how much interest you get per year. So it represents $60 per year in interest. Remember, gradient can sometimes be thought of as the change in the dependent variable when you have a change in one unit of the independent variable. So the change in the dependent variable here is the extra $60, and the change in one unit of the independent variable is for 1 year. So $60 per year in interest. Find the interest in 9.5 years is our second question. If you go back to the graph, go to 9.5 years, read up along that point, and then measure off the graph from there, you'll find that it is $570, there or thereabouts on the graph. You can, of course, use the formula that the I interest equals the P times by the rate. Sorry, 0.06 times by the number of years. That will get you the $570 exactly. Reading off the graph, you should find that it comes to roughly that point. Finding the time taken to earn interest of $250. What I would advise you do is you find $250 on the vertical scale, read across until you get to the line, mark that point on the line, and then read down to find out where it is. And it's roughly equal to 4.2 years. In an exam, they're going to give you some leeway. They'll let you be a little bit above or a little bit below. You're just generally looking to find that the student has picked the right place on the graph and has read down appropriately. If you make an error in your graph, you may still be able to get the points for the follow-on. So always look at your graph. Don't worry too much about trying to use the formulae. The reason these graphs are set up are so that you can answer questions like question 2 and question 3. Okay, so the book now says you should move on to exercise 803. As always, check the questions that you're looking to do on the inside cover of the workbook and ask for any help or advice about this video or the work that you're doing.